What's up, everybody? Welcome to another video. Hope you're ready to flex those brain muscles. In this video, we're going to practice factoring polynomials by grouping. Here's an example of what that looks like. Let's just jump right into it. This is a polynomial. We're going to factor it by grouping. The first thing we do is we want to look across all four terms, and we want to see, is there a common factor across all four terms? There's not, so then we move on to our grouping. What we're going to do is we're going to group the first two terms together, and we're going to take the greatest common factor out from those two terms. In this case, that's x squared. That's the biggest thing they share in common. When we take out an x squared, we're left with x plus 4. And how do we know that's true? Well, I can distribute this back in, and I should get exactly these two terms, which I do. So we took the greatest common factor out from the first two terms, and now we're going to do the same exact thing to the last two terms. In this case, the GCF is 5. We're going to take that 5 out. We're left with x plus 4, and this should always be what happens when we factor by grouping, is that what we're left with in these parentheses should be the same, right? If they're not, then it's either not factorable by grouping or we made some kind of mistake and we need to double check. So these are the same because this is how the factor by grouping works, is now we can think of this as being two terms. So we have this plus this, and these terms share a common factor of x plus 4. I know it's kind of weird to think about this binomial, right, being a common factor, things added together, but these two terms share that in common. They both have an x plus 4, so we can actually take that out. So think about taking this and this both out in front, right? Just like we would take out a common factor, just like we did up here, although it's a little weird. They're in parentheses, they're being added. We can still do it. We have that x plus 4 out in front, and what we're left with is x squared plus 5, which is what we have in parentheses here. So how can we check our work? Well, we're thinking about distributing this entire thing. Don't FOIL, don't draw a box, just distribute this entire thing times x squared. That's what we have here, x squared times x plus 4, and then times 5. That's what we have here. So this equals this, which equals this, and that's what we want to do when we factor. We don't want to change the expression. They should all be equal. And the final thing we just have to do is check, can we factor it down further? And in this case, we can't. This is not a difference of squares. There are no more common factors. We're good to go. We just factored by grouping. That's it. That's the end of this video. Just kidding. We got 4 more examples. So we just did this one. We're going to do 4 more. I'll have the video time stamped up so you can skip around. I encourage you, pause the video, try some of this on your own, skip around, use this in a way that helps you the most. So let's jump into our first example here. And again, the first thing we always want to do is look for a common factor across all 4 terms. I don't see one. Right here, we maybe have 2 because that's even, but then that's odd and that's odd. 3 doesn't work. I mean, 5 is prime. This is divisible by 5, but these are not. They don't all have an x, right? This doesn't have an x. So no, there's not a common factor across all 4 terms. We're going to move on to our next step, which is grouping. We're going to group together the first 2 terms, and we're going to look for the greatest common factor between those 2 terms, okay? So what is the greatest thing that I can divide out of both of them is one way to think about it. So I see 5 and 10, so I can definitely take a 5 out. And I see x cubed and x squared. So how many x's can I take out? 2 of them, x squared. What am I left with when I do this? Well, here I'm left with exactly x. So one way to think about this is, what do I multiply 5x squared by to get 5x cubed? That's just x. So one way to think about it as multiplication. The other way to think about it is, well, when I divide 5x cubed by 5x squared, what's left? That's x. So 2 different ways to think about it. I prefer to think about multiplication, but you do you. All right, so again, we could do the same thing. What do I multiply 5x squared by to get negative 10x squared? Well, I know it's going to be negative. I know from 5 to 10 we got to have a 2, and we have x squared and x squared, so that's actually it. And again, I could have done the same thing here. I could have divided this by 5x squared. The x squareds cancel. I'm left with negative 10 over 5, which is negative 2. Either way works. All right, we're moving on. We're going to group these together. What's the greatest common factor? That should just be 3. And what we're left with is x. That's what I multiply 3 by to get 3x. And then 3 times negative 2 is negative 6. Remember, we always want to think about that sign as well. Awesome. And we know we did it right because x minus 2 and x minus 2, remember, these things in parentheses should line up. They should be the same. Otherwise, we got to check our work. Or perhaps the thing isn't factorable by grouping. And now here's what we're going to do. These are now common factors. We can think of this as 2 terms separated by plus, and they both have an x minus 2 in them. So we're going to take that out in front. Boom, Boom, both coming all the way out in front. What we're left with is 5x squared plus 3. So let me write it. The x minus 2, the x minus 2 are factoring out in front, and we are left with 5x squared plus 3. And so the last thing we're looking for is this factorable anymore? Like, is it a difference of squares? Is there another greatest common factor we can take out? And the answer is no. This is as fully factored as we can get. And that's it. We just factored by grouping. So let's kind of summarize what we did in some steps. I know students very often like steps. So here you go. You can pause the video. We're looking for a GCF across the entire thing. If there is one, we take it out. If there isn't, we don't. And we'll see one example where we do that. We're grouping the first two terms, taking out that GCF, last two terms, taking out that GCF. Then we're taking out that new GCF. That's just what I called it here. It's what's left in the parentheses. So in this case, it was those x minus 2. We're taking that out. That's really our last step, except for checking to see if you can factor further, like if you're left with a difference of squares or something like that. Awesome. Hopefully this makes sense. Let's go into our second full example here. So again, first thing I'm doing, checking is there a common factor across all 4 terms. When I check that, I'm really quickly looking for 2 things. One, does every single term have an x in it? If it does, then we for sure at least have an x we can take out. So that's not the case here. For example, this 3 is just a constant, and now I'm looking at the numbers, 12, 9, 4, 3. Are they all divisible by the same thing? Definitely not the case here. In fact, even just 4 and 3 aren't divisible by the same thing. So we're good to go. We can move on and start our factor by grouping. So what do 12 and 9 share in common? That should be 3, should be the biggest number they share in common. And then x cubed and x squared, that means we can take x squared out, right? This is 3 x's multiplied together. This is 2 of them multiplied together. So they both have 2. That's the most they share in common. What are we left with? What do we multiply 3 by to get 12? That's 4. What do we multiply x squared by to get x cubed? That's just x. And now we're moving on to this next term. What do I multiply 3 by to get negative 9? That's negative 3, so minus 3. And you could have also instead just copied down the minus and just thought of this as a positive thing and moved on to that. I see a lot of kids do that. Totally works. So 3 times 3 is 9. So I can put the 3 here. And that's it. We already have the x squared. If I distribute this back into check, I get exactly what I had up here. So we're good to go. We can move on. And this next part is actually really tricky for kids. It's actually really tricky. They don't share anything in common. So what do? What is the GCF if 2 numbers don't share anything in common? It's just 1. Really important we write this step. Really important to write plus 1 here and then write 4x minus 3, because when kids don't, I notice them typically do really weird things. Like at least half the time they get it wrong because they do weird stuff. So let's write that plus 1 here. And why I like to do that is because now it's more clear. We have a common factor here and here. Remember, 2 terms. There's that new common factor in parentheses. We're going to take that out in front, 4x minus 3. And now what we're left with is 3x squared plus 1. This is the factored form. So the most common mistake I see kids make is they just write 3x squared because they forget to write this plus 1. They aren't really thinking about it like they should. So plus 1, we need that there. Please write it there. If they don't share a common factor, write a 1. And that's it. This is not factorable further. We are good to go for this example. All right, here is our next example. First thing I'm looking for, common factor across all 4. Let's see, are they all even? No, there's definitely not an x in all of them. This is just a constant. I think we're good to move on. There's no common factor across all 4 terms. So I'm going to move on and start grouping. And I'm going to look at the first 2 terms here. They definitely share a 2. And they share an x squared. So let's take 2x squared out. And what are we left with? 2x and then minus 1. So I did this kind of quick. Here's a pro tip. You know you took out the GCF when there's no more common factors in here. For example, if I forgot this 2, then I would have 4x minus 2. So if you notice in here there's still a common factor, then you didn't take out the GCF. Hopefully that helps. If we distribute this in, we get exactly where we were, so we're good to go. And now we can move on. We're going to group these together. We're going to take out the greatest common factor, which between 18 and 9 is 9. Again, they both don't share an x, so we're going to leave the x in there. So we're going to take a 9 out, but here's what's actually tricky. What are we doing here? We just wrote a parenthesis after negative 9. That means when I distribute negative 9, I need to get back to what I had up here. So one way to think about it is we're not really factoring out 9. We're factoring out negative 9. right? So let me erase this so we can clearly see what we had up here. We had negative 18x. So this first term needs to be negative. And here we had positive 9. So the second term needs to become positive. So what do I need to do? Well, that first term needs to be negative 18x. So what can I multiply negative 9 by to get negative 18x? That's just 2x. And now what can I multiply negative 9 by to get positive 9? That is negative 1. So that's really the way we think about it. We want to think about this sign being attached. And when we're asking ourselves that question of what do we multiply this by, we want to include that negative. So another way to see it, and how a lot of students say it, is the sign switch. Totally fine, that is true. Finally, we notice that these are the same, which is what we always want. So if we didn't take this out and maybe we didn't notice this and wrote this as a plus or something weird, hopefully we would realize it and fix it because we would realize these aren't the same. We must have done something wrong. All right, sorry if I digressed. We're going to take out this common factor of 2x minus 1 out front. And what we are left with is 2x squared minus 9. This is almost a difference of perfect squares. If that 2 was not there, then it would be, and I would factor down further. But since it is, I'm just not going to worry about it. I'm going to leave it like this, and we're going to say this is factored as much as we need it to be. Final example. Let's check for the common factor across 4 terms. You knew I was going to give 1, and this is the last one, so it's got to be this one. And again, what's the signal? How do we know? All of them have an x, so we can definitely take out an x. So now the question is, can we also take out a number? Are they all divisible by something? 3, 9, 12, 36. Are they all divisible by 2? Well, no. 3 and 9 aren't even. What about 3? 3 is, 9 is, 12 is, and 36 is. And I think that's the biggest because we already have a 3 here. So that's what we're going to do. We're going to take a 3x out from the entire polynomial. What are we left with? Here we're left with x cubed. That's what we multiplied 3x by to get 3x to the 4th. Here we're left with 3x squared because that's what we multiplied 3x by to get 9x cubed. Now what do we multiply 3x by to get negative 12x cubed? So it's got to be negative. 3 times 4 is 12, so there's got to be a 4. And then one more x. X times x is x squared. Finally, this has to be negative. What do I multiply 3 by to get 36? That's 12. And then we're just chilling there. We already have the x we need, so we can close off these parentheses. And now here's what we're doing. We're factoring by grouping with this right here. And the 3x is just going to chill out in front and hang out for the ride the whole time. That's all we do. Awesome. All right, let's factor by grouping now. We're taking the greatest common factor out from those first 2 terms, which is x squared. We have x squared, that's what they share in common, times x plus 3. I like to use a big bracket in the end. 3x is chilling because I know I'm going to have parentheses in here, and I just like to not use the same thing. I don't know, just personal preference. All right, now what are we going to have here? Let's see, minus, what's the greatest common factor here? We are taking out a 4, but technically we're going to take out negative 4. How is it that I know that? Well, there's already a negative here. That's one signal that we have. To maybe we're going to take out negative 4. The other is, remember, I want to end up with x plus 3. And if I want to end up with this being a plus, then that means I kind of have to take out a negative. So 2 ways to think about it. All right, when we take out this negative 4, what are we left with? Just an x here. Negative 4 times x is negative 4x. And what do I multiply negative 4 by to get negative 12? That is positive 3. Positive 3. Awesome. So we're going to write this out. Again, we had these big brackets. The 3x is chilling out in front. Now what we can do is take out the common factor, x plus 3, x plus 3, and what we're left with is x squared minus 4. So here's what we're going to write. This is equal to 3x, big bracket, x plus 3 we took out in front, and we are left with x squared minus 4, which actually is a difference of squares. Remember, that's our last step to check if anything left is easily factorable, and in this case it is. So I'm going to factor this difference of squares as x minus 2 times x plus 2. Remember, that's the formula. A squared minus b squared equals a minus b times a plus b. Ran out of room. Sorry, I couldn't write it better. Awesome. So here's our final factored form here. 3x times x plus 3. And I'm going to replace this with x minus 2 times x plus 2. Hey, wait a minute, what happened to the brackets? Well, we don't really need them. It's multiplication. I don't need another bracket here. It's just this times this times this times this, right? All multiplication, so we just write it all next to each other. Wasn't that fun? Wasn't that cool? We took this entire big thing and we broke it down into a bunch of different factors. Super fun. Hopefully this video helped. Hopefully you enjoyed it. Leave comments below with any questions. Subscribe to support me. Do all that stuff. And most importantly, keep flexing those brain muscles. And I'll see y'all later.